radiator, though perfectly normal in appearance, has undergone a savage and brutal attack. Since installation, it's been living in an untreated heating system. It looks as good as new, but it conceals a dark secret. Unseen, unheard, no one would have guessed it was there. Corrosion. But this enemy isn't limited to a single radiator. It's out to destroy the system. Our task is to investigate the clues to corrosion, analyse the causes, and point out the solution. And where better to begin than here at Fernox's Technical Services Department. Following the introduction of small-bore domestic heating systems in the 50s, Fernox quickly recognised the dangers of corrosion and became the first company to concentrate on preventing it. Today the result is a complete range of corrosion proofers and a whole family of other products, including chemical cleaners, antifreezes and many others. But not only has the product range grown, applications now cover everything from small domestic to large industrial systems. The technical staff here spend a lot of their time advising heating engineers, installers and specifiers. Advice on the correct treatment to solve a particular corrosion-related problem. The analysis of samples from treated systems and failure analysis on behalf of original equipment manufacturers. They're all part of a complete support service that keeps them in constant touch with the practical realities. Although most people are aware of corrosion problems, it's surprising how little is really understood. So let's investigate. We don't have to search far to see the effects on the heating system itself. The clues are everywhere. Thanks to corrosion, oxide sludge forms continuously and drifts around, often settling in the boiler where it causes noises that can be heard throughout the house. It won't be long before new boilers also become noisy if they're fitted to a system that hasn't been Fernox treated. Apart from boiler noise, in an untreated system there can be fuel wastage of 10 to 35% in as little as 5 years. This is because heat transfer is reduced by a build-up of sludge and scale, which creates an insulating effect. Eventually the boiler is likely to overheat and fail altogether. Here are some more clues. Equally vulnerable is the pump. Black oxide sludge, being abrasive and magnetizable, is attracted to the shaft and bearings in modern canned rotor pumps. This is the most common cause of circulating pump failure. It leads to shaft and bearing wear, and eventually the pump will seize as this one did. Scaled pipework lowers the effectiveness of the system by restricting the water flow. And performance is further reduced by motorized and thermostatic valves becoming blocked with corrosion debris. Radiator output is also reduced as sludge accumulates at the bottom, restricting the water flow pattern and causing cold areas. And as a byproduct of the corrosion process, hydrogen forms, again causing cold areas. Because it collects at the top of radiators and necessitates frequent venting, it's often mistaken for air. Add to these secondary consequences the primary problem associated with corrosion, such as failed radiators which can pinhole within months or even weeks of installation, and the price of failing to treat the system becomes high indeed. High because the effects of corrosion can irreparably damage the reputation of both the equipment manufacturer and the heating engineer, and indeed the reputation of wet systems as a whole. And high because of the time spent carrying out repair or maintenance work under guarantee. Repairs that will need repeating unless remedial action is taken. So if the evidence points to corrosion as the cause of many everyday problems, what causes corrosion? Investigating this question demands specialist analysis. The trail of destruction is marked by numerous corrosion-promoting conditions. We'll do some forensic work into just a few of the commonest. Oxidic corrosion, creating red oxide like this, occurs when oxygen is present. The simple act of filling a system introduces both trapped air and oxygen already dissolved in the water itself. Fresh oxygen can be entering a system all the time. For example, through porous joints or micro leaks, especially on the suction side of the pump. Micro leaks are small porous tracts that permit the passage of air into the system but don't allow water out. So the source of the problem is extremely hard to locate. In addition, any water loss is compensated for by the introduction of fresh oxygenated water from the feed cistern. Faulty design or installation can also result in oxygen entering the system. For example, through pumping over. Here, system water is literally pumped out of the open safety vent pipe into the header tank, where it's re-oxygenated and passed back into the system. Similarly, an incorrect open safety vent, cold feed and pump arrangement can cause re-oxygenation through seesawing of the water level. Pumping over or seesawing can also be caused simply by the pump duty being incorrect. But even in a correctly designed and installed system, some oxygenated water from the feed and expansion tank will enter the system gradually. Furthermore, take the venting devices on radiators. Because these are rarely sited at the highest point, radiators can't be filled totally with water. So a pocket of air is left trapped in the top of each one. The use of plastic piping will lead to further oxygenation because oxygen is diffused through the plastic into the water. The reality is that enough oxygen to promote oxidic corrosion is present in virtually all heating systems. But even in the virtual absence of oxygen, corrosion can still occur in the form of electrolytic corrosion. This is promoted by the presence of mixed metals, such as steel and copper, plus water acting as an electrolyte. The very elements that are basic to modern central heating systems. The mixed metals, connected by the water, cause a current to flow. This results in the least noble of the two metals, in this case steel, corroding. By connecting an ammeter to a piece of copper tubing and some steel from a radiator, the current can actually be read. Unfortunately for heating systems, the higher the temperature of the water, the higher the rate of corrosion. Apart from the simple presence of dissimilar metals, electrolytic corrosion can be promoted, for example, by the different constituents of an alloy and impurities in the individual metals themselves, particularly radiator steel, for which no British standard exists. Magnified 200 times, this is the result. Short-circuited electrolytic cells on the surface of the radiator steel. The effect is pitting and eventually pinhole perforations. Electrolytic corrosion can also be accelerated by the presence of crevices, which form, for example, under deposits of corrosion debris or even brick dust and sand, which we know can all too easily be left in a new system. This is often called crevice corrosion. Self-cleaning soldering fluxes are also often associated with corrosion damage. It's a matter of some controversy, but there's no doubt that excessive amounts of flux residues can cause short-circuited electrolytic cells by depositing copper oxide directly onto steel. Damage can also be caused to pumps and other control equipment. However, sensible use of fluxes and correct flushing procedure at the commissioning stage will do much to eliminate these problems. The conclusion is simple. In heating systems where mixed metals are used, and that's just about all of them these days, corrosion is inevitable and continuous. Another cause of corrosion is the water supply itself, the corrosiveness of which depends on its chemical makeup. High levels of chlorides and sulfates increase corrosiveness, and indeed soft waters are more corrosive than hard waters. Corrosion is also promoted by bacteria. They're particularly active under debris and can cause perforations even in heavy gauge steel. These and other causes of corrosion, such as electric currents caused by leakage faults, stressed areas in steel, and even the use of some dangerous corrosion inhibitors, which can themselves tolerate or cause localized corrosion, all lead to this. Black oxide sludge, formed from the metal that should still be part of the radiator. Any one of these factors can reduce the service life of a radiator to only a relatively few years. But adverse conditions have been known to reduce it to a matter of weeks. It's clear, therefore, that modern heating systems have an inbuilt ability to self-destruct. The solution is surprisingly easy to find. The few pounds it costs to include a Fernox corrosion-proofing treatment, far less than 1% of the system's replacement value, means an end to problems that have their real roots in corrosion. Don Hayes is a heating consultant with many years' experience of using Fernox.
The more responsible, the more experienced and competent engineers who install domestic central heating so that there are no functional faults, and who also add Fernox as a corrosion proofer, can leave the job and get the money and go away and have no further anxieties at all. And this is one of the reasons why I have every confidence in Fernox as the final finish to any job.
One treatment of Fernox corrosion proofer can last a lifetime, with perhaps only minor topping up every 10 or 20 years. The long and short-term effectiveness of Fernox corrosion proofing is easily demonstrated. 2 containers of ordinary tap water were heated. The temperature was 60 degrees centigrade. Remember, corrosion increases with temperature. Identical steel plates and copper tubes were placed in each beaker, but a correct amount of Fernox corrosion proofer was added to the beaker on the left. After only half an hour, metal in the untreated water began showing signs of corrosion. 24 hours later, and clear signs of corrosion can be seen. A week later, and the difference is dramatic. Unlike the metal on the right, the metal in the Fernox treated water remains totally corrosion-free. And here's what Fernox treatment has achieved over a longer period. In August 1973, 2 bottles were filled with an unpainted section of steel radiator, a piece of copper pipe, and plain water. Fernox corrosion proofer was added to the bottle on the right. Now, after all these years, there are no signs of corrosion whatever. But in the bottle on the left, which wasn't Fernox treated, the radiator cutting is standing half buried in its own iron oxide sludge. Identical bottles were filled at the same time for display at the Building Centre in London, where they're available for inspection. Brian King, the group exhibitions manager, was a witness.
Well, some representatives from Fernox came to the exhibition site and filled 2 bottles with plain London tap water, added Fernox to one of them, sealed the tops. This was carried out in front of myself and some other colleagues who were in that particular exhibition area at the time, and this took place in the summer of '73, and the bottles have been since then on show permanently to anyone who wishes to visit the exhibition and seek information on central heating as a subject.
Fernox chemical cleansers are designed to restore systems efficiently by removing corrosion debris. For new systems, commission cleanse with Fernox BC10 to prevent initial limescale formation and neutralise flux residues before they can do any damage. Fernox BC10 can also be used to eliminate boiler noises from tubular boilers in systems up to about 6 months old. Beyond that, systems up to about 12 years old can be safely cleansed with Fernox DS40, followed by BC10 for neutralising. Fernox DS40 dissolves sludge and scale, sometimes making the interior of a system cleaner than when new. It does not attack the metal. For systems over 12 years old, the recommended method is to flush the entire system with the aid of Fernox Superflock, then descale the boiler separately using Fernox DS40. Superflock is more suitable than DS40 in older systems where hardened sludge and scale may be blocking previously formed pinholes. By dissolving all the sludge and scale, DS40 may expose these existing leaks. But by contrast, Superflock aids the flushing out of the soft sludge only, and so avoids the danger of leakage. Finally, treat with a Fernox corrosion proofer. Each Fernox corrosion proofer has been formulated to serve its own specific application. Systems with cast iron boilers, copper tubular boilers, systems that include aluminium components. Whatever the combination, Fernox corrosion proofers not only prevent corrosion, but can also prevent limescale formation and bacterial contamination, lubricate the circulating pump, and prevent boiler noises.
It is quite impossible to offer one fluid which is a panacea for all evils. Fernox has to be applied in the right quantities to the right specification, and there is no reason at all why there should be any doubt or difficulty in using the stuff properly and responsibly and successfully, which can't be said for some of the new products. That's valid because with so many of the other inhibitors, we don't know that they are proof against corrosion. Quite a few of them have to be renewed periodically, whereas Fernox applied in the proper quantities to a watertight system is good for 20-30 years.
You can rely on Fernox for a comprehensive technical advice service and a commitment to research and development. To heating engineers, installers and consultants, that means more profitable use of time, improved reputation and a value-added service that really pays dividends. To public authorities, housing associations and householders, it means reduced maintenance costs and long-term protection of valuable assets. It all adds up to the only possible solution.